transform. Okay? Fourier transform and correspondingly and the related problems here. When you concentrate on the Fourier syllabus, Fourier transform technique here, Fourier transform technique, you will see what will be the syllabus you have. Yes, it starts from Fourier integral theorem statement only, and then based on that, infinite, finite Fourier sine and cosine transform, and transform properties here, convolution Parseval's theorems here, and initial and boundary value problems here, and here we have infinite and finite Fourier and its inverse Fourier sine and cosine transform, everything is here, and initial and boundary value problems here. And the initial and boundary value problems that involves the transverse vibration of string and vibration of the string. That type of problem we have here. Therefore, we start with that Fourier transform definition with the help of Fourier integral theorem. Fourier integral theorem. Um, uh, we have already written notes for the other section. Therefore, based on that, we will discuss today. Okay. I will read somewhat slowly. You can copy that. Okay, you can copy that here. We has already written statement the same thing. Therefore, no need to write these statements once again here. Fourier transform definitions basically comes from the Fourier integral theorem statement. Fourier integral theorem statement. These Fourier integral theorem statements are derived from Fourier series ideas. Fourier series ideas. Fourier series ideas here. Therefore, we have Fourier integral theorem. What it says that here, if f of x is piecewise continuous, in every subinterval, of minus infinity comma infinity, f of x is piecewise continuous in every subinterval of minus infinity comma infinity, and is f of x is also integrable function, integrable function in minus infinity comma infinity. F of x is piecewise continuous in every subinterval of minus infinity. Suppose f of x is defined in the interval minus infinity to infinity, somewhat of piecewise, somewhat of many subintervals here. Then in that case, it should be a piecewise continuous function. It is also integrable function. Then f of x can be written as 1 by 2 pi double integral of minus infinity f of t e power is of x minus t dt dsv. F of x can be written in terms of double integral of the same type of function with other variable. Same type of function. It's the same f of x you can use here. Same f of x you can use. That can also be represented like this in terms of double integral form. Fourier integral theorem. This is Fourier integral theorem. This statement can be derived with the help of Fourier series definition. Fourier series says that f of x can be written as summation in the infinite series summation n equal to minus infinity complex form Cn e power minus in by x by L, that one here, where Cn equal to 1 by 2L integral minus infinity f of x e power minus in by x by L dx in that one. You substitute that Cn inside the integration and then write summation of integral as integral of summation, and write summation once again in terms of integral form. If you convert that here, we can get the same this kind of relation. So you can get this kind of relation 1 by 2 pi integral minus infinity integral double integral minus infinity. That summation and integrals are converted as a double integral form here. F of t e power is of x minus t dt ds. This is the proof derived from the Fourier series idea. Now you can split this Fourier integral theorem with respect to t, with respect to s is here. You can split s and t functions here, e power isx and e power ist, e power isx and e power minus ist, that type of form here. But also write this 1 by 2 pi for two integrals here, 1 by root of 2 pi and 1 by root of 2 pi here, 1 by root of 2 pi. And first consider with respect to t, inner integral, with respect to s outer integral. With respect to t means f of t e power minus ist, you can get f of t e power minus ist, you can get dt, and then you can get e power isx, e power isx ds, e power isx ds, in that manner you can get that. Therefore, if you split d with respect to t and with respect to s differently, separately here, with respect to t, wherever t comes here, we will have first here f of t here, e power minus ist dt. That will be the condition you can get. Then separate s e power isx here, e power isx with respect to s here. Now, this integral, inside integral with respect to t takes the limits minus infinity to infinity, minus infinity to infinity. Therefore, after integration, if you apply t takes minus infinity to infinity, okay, minus infinity to infinity, the result will be a function of s only. Okay, result will be because s only remains here, t takes the limits here. Therefore, result will be a function of s. This part is called as a Fourier transform. This is called the Fourier transform of the given function f, the given function f. This is called as a Fourier transform. Then the result will be a function of s. You substitute f of s here. Then 1 by root of 2 pi into minus infinity to infinity. The whole thing will be a function of s. F of s e power isx. It is function of s. Here is also s with respect to s. This is Fourier transform. Then if you integrate, if you apply that Fourier transform once again here you can get what the original function f of x here. You can get original function f of x here. That gives the inverse Fourier transform here. Inverse Fourier transform. This will be the idea you can get that with the help of one integral. You can get that original function that is called inverse Fourier transform. Therefore, this part is Fourier transform, and then apply the Fourier transform result here in this integral. You can get original function that is inverse Fourier transform. These are the definitions you can get here. Well, you take this result as a f of s, function of s, function of s, 1 by root of 2 pi minus infinity to infinity f of t power minus ist dt as a function of s. Then we can get f of x, f of x can be written as 1 by root of 2 pi into minus infinity to infinity f of s e power isx ds, f of s e power isx ds. For this equation 1, this part already known, this condition f of s here, the result will be a function of s. This is called Fourier transform of f of x. Called Fourier transform of f of x. And this is called equation 2 is called inverse Fourier transform of f of x. Equation 2 is called inverse Fourier transform of f of x. Wow. Right. Now function is same, function f of x. Instead of f of x, you are using the variable only changed here f of t, but function is same. Instead of f of t, you can use the term as a f of x. You can use the variable as a f of x. Here is also you can change it as e power minus isx dx. So from this, just note down this slide. Note it down that this part is equal to f of s. Then obviously, already we discussed in the previous one here. Previous one, yes. This is f of s, and if you take this as f of s, you can get original function here. Therefore, it is called inverse Fourier transform. It is called Fourier transform. Equation 1 is called Fourier transform. Equation 2 is called Fourier transform of inverse Fourier transform of f of x. All right. Now we can write the definition in the convenient form. Therefore, you can write the definition in the convenient form. If f of x is defined in the interval minus infinity comma infinity, f of x is defined in the interval minus infinity comma infinity, then its Fourier transform is given by, if f of x is defined in the interval minus infinity comma infinity, then its Fourier transform is given by, Fourier transform f of x. Fourier transform f of x equal to 1 by root of 2 pi, you have to multiply integral minus infinity to infinity the function f of x into e power minus is, which is this kernel. This is a fixed one here, e power minus isx dx here. This is a fixed part. Like Laplace transform, we have e power minus st. Here that kernel is e power minus isx here, equal to f of x. Result will be a function of s here. You see the Fourier transform definition previously, 1 by root of 2 pi integral minus infinity f of t e power minus ist. But instead of f of t here, we are using f of x e power minus isx dx, e power minus isx dx f of x. And then at the other way, inverse Fourier transform, right? And the inverse Fourier transform is given by and the inverse Fourier transform is given by, we are going to adopt this f of s here. We are going to adopt this f of s here. That's also 1 by root of 2 pi before integral 1 by root of 2 pi integral minus infinity to the same limit. But we are going to adopt this f of s here, f of s. But instead of e power minus isx, you see that here e power plus isx. Here you can use plus isx here. E power plus isx dx. E power plus isx dx. This will be the with respect to s. That is very important with respect to s. With respect to s. If f of x is this is the inverse Fourier transform. This is the inverse Fourier transform. With the help of this inverse Fourier transform, what you can identify here, you can write f of x. You can write f of x as a infinite integral form here. As an infinite integrals of some functions here. Infinite integral of some functions here. Through Fourier series. Through Fourier series, what you write here, you can write f of x as a sum of infinite series of sine or cosine functions here, that type of thing here. Infinite series of sine or cosine functions, a n cos nx, a n sin nx here. So summation a n sin nx, summation a n cos nx, summation a n b n sin nx. Infinite series of sine and cosine functions here. Here is also the same idea here. Infinite integrals of this e power isx can be written as sine cos sx plus I sin sx. That type of form also can write here. For infinite integrals of sine or cosine function, that is also one of the. So through Fourier series, you can write any function can be written as any periodic that function defined, continuous function defined in the interval minus infinity comma infinity or 0 to 2 pi. That is a periodicity function that can be written as in the help of Fourier series as a infinite series of sine or cosine functions here. And here the Fourier transform, you can write infinite integrals, not infinite series, infinite integrals of sine or cosine functions here. That will be the definition we can. For this is Fourier transform definition. In the Fourier transform, we have to use e power minus isx. In the inverse Fourier transform, we have to use e power plus isx. But reverse also possible here. The reverse also possible. Suppose if you use plus here, you have to use here minus here. Some textbook follows plus here and here minus. That is depends upon your choice. That's minus for Fourier transform, plus for inverse Fourier transform. This is purely with respect to x, and here purely with respect to yes. Yes, it will be the definition. And today we'll see some problems based on this definition here, Fourier transform definition here. Before moving into that problem, because we are going to in the problems we are going to split the summations here. For that we need one property, linearity property. Linearity property. Fourier transform is linear. First one is the first property is that some properties we are going to see one by one, but initially we are going to see one property. First property that linearity property. That says that Fourier transform is linear. Fourier transform is a linear function. That is Fourier transform of f of a into f of x plus b into g of x. A and b are constants. A into f of x plus b into g of x. A into f of x plus b into g of x. A f of x plus b g of x is equal to a into Fourier transform f of x. We can take constant outside here. Similarly, you can split the summation here. Summation plus and b into Fourier transform of g of x. B into Fourier transform of g of x. Yes, proof is very obvious because it is addition only was splitting here. By definition, Fourier transform of f of x. Fourier transform of f of x is equal to 1 by root of 2 pi integral minus infinity to infinity. The definition of Fourier transform f of x, that is equal to 1 by root of 2 pi integral minus infinity to infinity f of x e power minus isx dx. This definition you have to remember always. 1 by root of 2 pi integral minus infinity to infinity f of x e power minus isx dx. F of x e power minus isx dx implies Fourier transform of a f of x plus b g of x. Fourier transform of a f of x plus b g of x. That is equal to instead of f of x here. Instead of f of x, we are going to replace by a f of x plus b g of x. B g of x. Yes, in this definition, you have to replace f of x by a f of x plus b g of x. A into f of x plus b into g of x. kernel as it is only e power minus isx dx minus isx. Or here you take a outside here, a 1 by root of 2 pi into minus infinity f of x e power minus is f of x e power minus is plus b. We take b because it is constant. We take it outside of the integration. B split the integral for this one here, addition here, plus b. We take integral outside of the integral. And 1 by root of 2 pi integral minus infinity g of x e power minus is dx. Yes. Yes, you see that here, this is nothing but again by the definition of Fourier transform 1 by root of 2 pi minus infinity f of x e power minus asx. So it is called as a into Fourier transform of f of x, this function. This is Fourier transform definition. Similarly here plus b into, this is Fourier transform definition of g, function g. B into Fourier of f of g of x, f of g of x. Or this is or you can, after this statement, you can write this one here. That is f of, that is f of a f of x plus b g of x. After this statement, we can write this one here. Fourier transform of f of a f of x plus b g of x is equal to a into Fourier transform of f of x plus b into Fourier transform of g of x. Yes, you study Laplace transform is linear, like that. Integral operator is linear, obviously. Therefore, with the help of that, for Laplace transform or Fourier transform, that two are linear, because Laplace or Fourier transform both depends on integrals. Both depends on integrals. Okay? Obviously, integral operator is linear. Therefore, these two transform also linear. Obviously, that you can get. Or this is, you have to remember. With the help of this, you can move on to some problems, simple problems. Okay? Right. In Fourier transform, we have some standard problems. We get into 12 problems for Fourier up to sine or cosine before applications. These problems are very important and also repeated problems here, and also standard problems here. Therefore, you have to give importance to all the problems of Fourier transform. All the problems are very important, and also standard level 10 to 12 problems only. Therefore, you can easily remember and consider. Right. Yes, first problem, show that the Fourier transform of f of x, Fourier transform of f of x is equal to a minus mod x, a minus mod x. All of you just note down Fourier transform of f of x is equal to a minus mod x, mod x less than a, mod x less than a, and 0 for mod x greater than a greater than 0. Mod x greater than a greater than 0 is, its result will be root of 2 pi pi, root of 2 pi pi 1 minus cos as by s square, 1 minus cos as by s square, and hence show that integral 0 to infinity, and hence show that integral 0 to infinity sin t by t whole square dt, sin t by t whole square dt is equal to pi by 2, sin t by t whole square dt is equal to pi by 2. And here you have to first see the given function here. This is a given function. For this function, you have to show that this is its Fourier transform. This is its Fourier transform. Then with the help of this, you have to reduce that integral value. Most of the thing at the initial level, Fourier transform is very much useful to solve some indefinite integrals. This kind of integrals, some indefinite integrals that cannot be solved in usual manner. Some real definite integrals cannot be solved in the usual manner. That type of integrals can be solved easily with the help of Fourier transform of some certain functions here. With the help of Fourier transform of certain functions here. Sometimes that integrals can be solved with the help of complex integration. Some integrals can be solved with the help of contour integration idea that you studied previous semester. Contour complex integration, contour integration idea is also useful to solve some real definite integrals or real indefinite integrals here. And here is also the same manner here. Some problems cannot be solved. Some integrals cannot be solved usually in ordinary way. Those integrals can be solved easily therefore Fourier transform of certain function. Okay, right. Yes, here you take the what is the given function. Given function f of x is equal to a minus mod x for mod x less than a and 0 for mod x greater than a. 0 for mod x greater than a. Mod x less than a means what about your meaning, implicit meaning? It lies between minus a to a. X is lies between minus a to a. Minus a less than x less than mod x greater than a. Mod x greater than a means what about your meaning? More than a, more than a. Therefore, a to infinity, and as well as because of modular symbol, less than minus a also you have to consider less than minus a. Modulus less than a means minus a to a. Greater than a also before after a below minus a. That is also you have to consider. Below minus a, that means minus infinity less than x less than minus a. That is also you have to consider. So under these two intervals, the value of the function is 0. Under this interval, the value of the function is a minus mod x. Therefore, by definition of Fourier transform, we can write that Fourier transform f of x is equal to 1 by square root of 2 pi. You know the definition once again, and you recall the definition 1 by root of 2 pi. Integral minus infinity infinity f of x, the function is same thing, f of x e power minus isx dx, e power minus isx dx. So 1 by root of 2 pi, integral minus infinity infinity f of x e power minus isx dx. Now this minus infinity infinity can be split like this here, can be split minus infinity to minus a, and then minus a to a, and then a to infinity. 3 intervals you can write. Therefore, minus infinity to minus a to a, plus a to infinity. You can split this minus infinity into 3 sub-intervals. F of x e power minus isx dx. E power minus isx is just fixed the kernel, you have to keep as it is here. Power minus isx dx. Substitution only you can replace. But already given that first and the last interval, the value of the function is 0. First and the last interval, value of the function is 0. In between that, we have a minus mod x. So a minus mod x. First 0, and here minus a to a. The function is a minus mod x, e power minus isx dx plus 0. 0. Last one is also 0. 1 by root of 2 pi interval minus a to a minus mod x e power minus isx, e power minus isx. Here you see that a minus mod x e power minus isx can be written as cos sx minus I sin sx. Yes, you see that here because of minus a to a, that type of relation, and also this is even function. This is even function. Mod x is present here, or you can split this e power minus isx as a cos sx minus I sin sx. Cos sx minus I sin sx. We can easily integrate. We can easily integrate with the help of even and odd function idea. And after this, we have only this integral with a minus mod x, and for our convenience, you write e power minus isx as a cos sx minus I sin sx dx. Okay, right. Because of this mod x is here and minus a to a, this is even function, and the cosine function. If you replace x by minus x here, cos of minus theta is cos theta. So this is even, and it is also even. Product is also even function. Similarly, it is even, but here if you replace x by minus x here, sine of minus theta equal to minus sine theta, you can get odd function. You take minus outside here, odd function. Therefore, I can get this is odd function, this is odd, this is even. If you multiply, you can get minus outside here because of this odd function. So that is totally odd function. The product is also odd function. This is even function and this is odd function. Then for even function, for minus a to a, minus a to a even function. How can you write? Anyone can tell that? Minus a to a inside is even function with respect to x. Integral minus a to a. How can you write
2
integral
into
minus
2
a?
into 0.
2 into 0 to a. Yes, very good. 2 into
So
0
it's a
to
root 2 by root of 2 by pi.
2 into 0 to a you can write. 2 into 0 to a minus mod x cos sx dx. But odd function, what about your result here?
0,
0.
sir.
0.
Therefore, you can write this is 2 into 0 to a, this is 0 here for sin sx 0. Therefore, we can write as 2 into 0 to a minus mod x cos sx dx. 2 into 0 to a minus a to a can be written as 0 to a minus mod x cos sx dx. And sine function is 0. This is minus 0. Minus 0. This is by even and odd function idea. Even and odd function idea. Even and odd function. Or you can write it 2 by root of 2 pi, or otherwise you can write root of 2 pi pi. Okay, root of 2 pi pi. Any manner you can write 0 to a minus mod x cos sx dx. A minus mod x. Now 0 to a, you have to integrate these two, product of two functions. Okay, product of two functions. Product of function. Before that, to integrate, because you have to remove that modulus symbol. Modulus symbol. So 0 to a is greater than 0. Already given that a is greater than 0 in the definition. A is greater than 0. Or positive. A is greater than 0 means positive. Therefore, this is positive. Positive. So 0 to a is positive range for x. Positive range for x. Therefore, x takes only positive values. Positive values. Therefore, no need of modulus symbol. Modulus symbol. So 0 comma a is a positive range. Positive range. Therefore, no need of modulus symbol. Therefore, we can write a minus x cos sx dx. No need of modulus symbol. There's a positive range. Now you have to integrate. For integration, product of two functions, you can apply Bernoulli's formula easily. That is very simple. Instead of integration by parts, Bernoulli formula is somewhat easy. You can easily adopt here. U and v. You take product of two functions here. U, v. You take u as always algebraic polynomial. Algebraic polynomial. What is Bernoulli's formula? U v1 minus u dash v2 plus u double dash v3 minus etc. here. Okay. First function u, and the second one is second part is integration of this function is u v1. After that, you have to put plus or minus symbol alternatively. First to plus and then minus, and then differentiate this one u dash, integrate this one v2 plus. After minus, you have to put plus, then differentiate this one u double dash, integrate this one v3. About differentiate first function, integrate second, differentiate first, integrate second. In that manner you have to move. You have to put plus or minus comes alternative. You have to put plus or minus alternatively. Okay, right. Therefore you can write you can write root of 2 pi pi. You write root of 2 pi pi. First function u as it is here, a minus x. Then integration of cos sx will be sin sx by s. With respect to x here, therefore you can get s in the denominator. Sin sx by s minus formula minus. This is formula minus. What about thing here? Differentiation of first factor minus 1. Then integration of second factor. Sin integration will be minus cos sx by s square, and plus formula plus differentiation of first factor 0. That's all. Whenever 0 comes here, you can stop the formula. Bernoulli's formula. Bernoulli's formula. And the limit is 0 to a. Limit is 0 to a. For first you write a u as it is here, and the integration of second factor, second function. Right. Then after that, differentiate this one, integrate this one. These two. Then differentiate this one, integrate this one. By differentiating this one, 0 comes here. Therefore, stop the process here. 0 to a. Now the limit is for the variable x. Limit is for the variable x here. Therefore, we take s outside here. Without x, what are the things are present? We take it outside. Here 1 by s, we can take it outside of the limit. 1 by s square is also can take it outside of the limit. So root of 2 pi pi, you can write as it is here. You can take 1 by s outside. In order to take the limits properly, take 1 by s outside. A minus x sin sx. A minus x sin sx here. Limit is 0 to a. And then a minus x sin sx, limit is 0 to a. And then here minus minus plus, and here one more minus 1 by s square, take it outside here, cos sx only. 1 by s square, take it outside, cos sx only for the limit. Limit is for only cos sx. Then root of 2 pi pi, you can substitute the limits. A minus a is 0. Okay. When apply 0, sin 0, 0. That's also 0. For 0 minus 0, okay. And apply a here for x, you can get minus 1 by s square, cos a s, a x instead of x a. That's why cos 0, 1, minus 1. And multiply by this minus, then you can get 1 minus cos as by s square. So root of 2 pi pi, 1 minus cos as by s square. Root of 2 pi pi, 1 minus cos as by s square. This will be your result here. That will be a function of s. So this is the result we expected here. The root of 2 pi by 1 minus cos as by s square. You see the question here. Root of 2 pi by 1 minus cos as by s square. Okay. So this is the result we expected, as also we derived it. Now, with the help of obtained result, they are asking that what will be the value of the this integral value here. That you are also you have to show the pi by 2, 0 to infinity sin square t by t square. 0 to infinity sin square t by t square. The obtained result, this is f of s, Fourier transform, Fourier transform. The Fourier transform obtained result 1 minus cos theta can be written as 2 sin square theta by 2. 2 sin square theta by 2. This is s square. Therefore, you can write as 2 sin square as by 2. 2 sin square as by 2. That you can write here s square. As by 2. 2 sin square as by 2. If you put as by 2 as a t, you can get sin square t. You can get numerator. Yes, this is sin square t. Denominator also correspondingly you can get some t by something, etc. T square by something you can get here. Therefore, if you take this f of s, this is Fourier transform. Fourier transform generally represented by f of s. F of s. Therefore, if you take this f of s inside the integration, you can get this kind of integral functions here, or this kind of integral functions here. But if you want to take f of s inside the integration, what about the thing? What about the definition you can follow? If you want to take f of s inside the integration, Fourier transform inside the integration, what definition you have to follow?
Inverse Fourier.
Inverse Fourier transform. Very good. Inverse Fourier transform. Yes. Because we have to get this inside the integration, f of s inside the integration, that is suitable with the help of inverse Fourier transform. Yes, your deduction is that you have to prove that integral 0 to infinity sin square t by t square dt equal to pi by 2. That is the thing you have to prove. You can write 1 minus cos theta as 2 sin square theta by 2. That's also you can. But by inverse Fourier transform, in order to get this result, by inverse Fourier transform, we have that is inverse Fourier transform definition. F of x is equal to 1 by root of 2 pi, that is obvious common, minus infinity infinity. F of s, you have to take f of s inside the integration into e power isx plus isx. This is plus isx, very important. Ds. He has already used minus isx in the definition. Fourier transform. So this is Fourier inverse Fourier transform definition. F of s e power isx. 1 by root of 2 pi integral minus infinity infinity. Apply f of s here. Obtain result f of s here. Yes, this is f of s here. Root of 2 pi by 1 minus cos as by s square. Apply here. Root of 2 pi by 1 minus cos as by s square e power isx ds. 1 minus cos as by s square. Then root of 2 pi pi and you multiply here. Root to root you can cancel. 1 by pi you can get. 1 minus cos as by s square you can write. Again, you split e power isx as a cos sx plus I sin sx form. Cos sx plus I sin sx form. Cos sx plus I sin sx form here. Then you can use even and odd function idea. You can split e power isx as a cos sx plus I sin sx. With respect to s here, integration is with respect to s. Therefore, in order to check even and odd function here, you change s by minuses. We change s by minuses, cos of minus theta, cos theta. We change s by minuses, s square is s square only. Change s by minuses, cos of minus theta, cos theta. Therefore, everything is positive, the same sign only. So this is totally even function. This is even. It is also even. Okay, even function. Now it is even, but here if you change s by minuses, sin of minus theta equal to minus sin theta. You are getting a common minus here. Therefore, this is totally a odd function. As an even function, you can write 2 into 0 to infinity. This minus infinity as here 2 into 0 to infinity. Because of odd function, you can write 0. Second level as here 0. Therefore, 1 by pi, 2 into 0 to infinity, 1 minus cos as by s square, cos sx ds. 1 minus cos as by s square, cos sx ds. This part is 0. Another part is plus I into 0. Second integral is 0. The even and odd function idea. Therefore, you have only relationship 2 pi pi integral 0 to infinity 1 minus cos as by s square cos sx ds. 1 minus cos as by s square cos sx ds. Now 1 minus cos theta can be written as 2 sin square theta by 2. Therefore, 1 minus cos as can be written as 2 sin square as by 2 by s square. And this is 2 pi pi. And cos sx ds. But in the deduction, in our deduction, we need sin square t by t square. There is no cosine term, this term here. Therefore, in order to eliminate this one, or you can treat it as a number 1, we put x is equal to 0. We put x is equal to 0. You can get left side is f of x, right side is also x here. For both sides, put x equal to 0 here. We can get some, because we cannot replace s value because we have to get sine square t by t square form, that we can replace finally. But here, if you eliminate this sign, this term, we have to put t is equal to sorry, x equal to 0 here, both left and the right side here. Because it is also x and here is also x here, in order to unaltering the result. But this is 4 pi pi. We can follow like that. Put x equal to 0 in the above equation. Left side is f of x at x equal to 0. Right side is 4 pi pi integral 0 to infinity sine square as by 2 by s square cos sx is equal to 1. Cos 0 is equal to 1. Therefore, we can get sine square as by 2 by. We have to get this as a sine square t form. You take as by 2 as a t. As by 2 as a t. So s is equal to 2t by a. Correspondingly, ds is equal to 2 dt by a. By converting s to t form here. S to t form. Correspondingly, some changes. And also, what about the limit when you change s to t here? When s is 0, t 0. When x is infinity, t is also infinity. Therefore, when s varies from 0 to infinity, t is also varies from 0 to infinity. There's no change in the limit. When s varies from when s varies from 0 to infinity and t is also varies from 0 to infinity, no change in the limit. I substitute all these ideas here. F of x at x equal to 0. That's also we require left side here. Left side we require f of x at x equal to 0. What about your idea? How f of x is defined? It is defined as a minus mod x for mod x less than a, 0 for mod x greater than a. Already given that a is greater than 0. 0 for mod x greater than a minus mod x for mod x less than a, and 0 for mod x greater than a. Therefore, minus a to a, because of a is greater than 0, minus a to a. Therefore, x equal to 0 we require here. F of x at x equal to 0. X equal to 0 is lies between definitely minus a to a, because a is greater than 0 value. So minus a to, between minus a to a, 0 is lies here. Therefore, 0 is lies within this interval. Therefore, you have the result of a minus mod x for left side here. Therefore, f of x is a minus mod x at x equal to 0. F of x is a minus mod x at x equal to 0 left side here. Right side, you put all the substitutions here. 4 pi by 0 to infinity sine square t. This is t. This is s is equal to 2t by a. You can get s square means 4t square by a square, and ds becomes 2dt by a. Okay, ds by x equal to 0 substitute here. You can get a left side here. Left side a. You can get a left side, and the right side is 4 pi pi, and here this is a square by 4, 2 by a square by 4, 2 by a, 0 to infinity sine square t square, sine square t by t square dt. This is sine square t by t square dt left side here. Now cancel. What are the things you can do that? 4 and 4 get cancelled. 1 a get cancelled, and one more a and this a get cancelled here. Everything get cancelled. Remaining thing is 2 pi pi. You take it left side here. It will be pi by 2. Pi by 2. 0 to infinity sine square t by t square dt. Yes, this will be the result you can get here. 0 to infinity sine square t by t square dt. That integral value is equal to pi by 2. This integral result, you cannot solve this integral in ordinary way. This Fourier transform technique only is very much useful to identify the value of this integral 0 to infinity sine square t by t square dt. This will be the idea. Therefore, based on the question here, question they asked that first find Fourier transform. Yes, we identified Fourier transform of this function. We identified this value. This is the Fourier transform of the given function. Then after that, with the help of this function, obtain the Fourier transform. You have to prove that sin t by t whole square dt square whole square dt is equal to pi by 2 here. So it seems that you have to, if you take this one into the integration, this is somewhat okay. For that purpose, you are taking inverse Fourier transform definition. You can and substitute. You can get the result here. You can get this. Oh, this will be the idea. You can get. Oh, right. This is Fourier transform definition for related problems. Fourier transform definition related problems. Now, the same manner, all of you try this problem here. Find the Fourier transform f of x. The same type of problem, same type of procedure. Just use the definition of Fourier transform. Find the Fourier transform f of x. Very simple problem only. X equal to 1 for mod x less than a and 0 for mod x greater than a greater than 0. Same definition. This is constant function only. 1 is a constant which you get outside here. Find the Fourier transform f of x 1 and hence find the value of integral 0 to infinity sin t by t dt. This is sin square t by t square, but here this is sin t by t only. Sin t by t dt. What is the value of this integral? Can you give the answer? All of you try the second problem and give your answer. All of you try the second problem. Yes, all of you try and give your answer. Yes, what about your answer for Fourier transform? Fourier transform.
Square root 2 by pi sin as by s.
Yes, very good. Square root of 2 pi pi sin as by s. Yes, that is present in the screen here. Square root of 2 pi pi sin as by s. Yes, sin as by s, here sin t by t in the direction. We have to take it into the inside the integration. Use inverse Fourier transform. Use inverse Fourier transform. Again, same idea. We're getting sin as by s. Here sin t by t. Both are same like same. So take apply inverse Fourier transform. What about your answer? Integral and value. Internal value, 0 to infinity sine t by
Pi
2
by
d. Yes, pi by 2. Your answer will be pi by 2. Yes, all of you, please check your answers. You are getting the same answer or not here. Your Fourier transform is root of 2 pi pi. Root of 2 pi pi sine as by s. Sine as by s here. Then if you get it inside the integration with the help of inverse Fourier transform. Inverse Fourier transform, you can get, you have the answer of pi by 2. You have the answer of pi by 2. Yes, this will be your answer. And tomorrow, as like our changed timetable, tomorrow we have a class around 9:45 to 10:45. 9:45, 10:45. And I will take some extra 15 minutes or 20 minutes. Uh, Up to 11 or 11:05, 11:10. We can catch up the that missed class. Yesterday we missed a class. We can catch up with the help of that 20 minutes. Okay. Right. Okay. That's all this session. Today we discussed about Fourier transform and related topic. Fourier transform definition and related problems with the help of the definition.